Welcome back, everyone. So before the break, I defined that an arithmetic series is when we add the term values of an arithmetic sequence together. Now we're going to be looking at examples on how we can actually calculate the value of an arithmetic series. Let's have a look at our first example together. So we have been asked to find the sum. The second you see the word sum, we know that it is a series of the first 10 terms of the arithmetic sequence. 4 plus 7 plus 10 plus going on. Before the break, we defined that Sn is equal to n over 2 times 2a plus n minus 1 d. What we are going to need in order to actually calculate Sn is to plug in the values for n, a, and d. The sum of the first 10 values will be equal to 10 over 2. Why am I substituting in 10 for n? I've been told that the first 10 terms needed to be added together. So n is equal to 10. I now then need to substitute in 2a. A is a value of 4. So it's going to be 2 times 4. Then I'm going to add this to n minus 1. I know that n is 10 because I'm summing the first 10 terms, so it's going to be 10 minus 1. And my common difference, if we look between the terms, I can see that a value of positive 3 has been added each time. So my common difference is 3. Now if I simplify this next line, the sum of the first 10 terms of this series will be 5 times 8 plus 9 times 3. Now I can get my calculator out just to make it a bit faster. I'm going to have 5 times 8 plus 9 times 3. So everybody, the sum of my first 10 terms of this particular series is 175. So everyone, I hope you're with me. S10 equals to 175 means that if I add the first 10 terms of the sequence together, I'm going to have an answer of 175. Let's have a look at the next example together. So, sorry guys, there's some space for working, but we've already done it. So we are going to now determine the sum of the arithmetic series. So, we know that arithmetic series go Sn is equal to n over 2 times 2a plus n minus 1 times d. Before I get into this example, I want to show you something cool with regards to this particular formula. I'm sure everyone will agree with me that I can actually write Sn is equal to n over 2, open brackets, a plus n minus 1 d. The reason why I can do this is all that I've done is I've written 2a as a plus a. Why on earth I am doing this is because it's actually going to help me write an arithmetic series in a simpler form. Because I can replace a plus n minus 1 times d with an L. Because we know that a plus n minus 1d refers to the last term of the sequence. So this means that Sn is also equal to n over 2 times a plus the last term of the sequence. So that means I can use this form to determine the series, or I can use this form to determine the arithmetic series. Please note that I can only use the second one when I actually have the value of the last term. So for this example, I've been asked to determine the sum of the arithmetic series that starts at negative 12, then negative 5 plus 2 plus 9, going the whole way to 121. So because I have the last term, that means that I actually can use the second form of the series. So guys, let's get going with this example. I'm going to use the series form of Sn is equal to n over 2 a plus L. I'm using this form as I actually have the value of the last term. But before I do that, I need to be able to substitute in a and n. A is negative 12 because I know that that is the value of the first term. But an issue is going to come because I don't know what the value of n is yet. And I need to know the value of n because I need to know how many terms are actually involved in this sum. Great, guys. So I've said a lot of different things, but I hope that everyone's still with me. In order for me to substitute into Sn, I need to know how many terms are in this sequence. If I actually know what the value of the last term in this sequence is, I can use the arithmetic sequence form. So I'm going to leave the series formula for a few seconds. I'm going to use the arithmetic sequence form of Tn in order to determine n. Let me write it on the board so everyone can be with me. I'm going to use Tn is equal to a plus n minus 1 times d to determine n because I know that the value of the last term is 121. So I'm going to substitute in 121 for Tn. A is negative 12. I'm solving for n, so it's still going to be n minus 1. And my common difference, if we have a look at our question, we can see the positive 7 is our common difference that we have added each time to the different terms of the sequence. So going back to the calculation, it's going to be times 7. So the next line will be 121 is equal to negative 12 plus 7n minus 7. Then my next line will be 121. Negative 12 minus 7 is negative 19 plus 7n. I'm going to take the negative 19 over to the left-hand side, so I'm going to add 19. So I'm going to be left with 140 is equal to 7n. So dividing both sides by 7 will give me that n is equal to 20. Great, guys. So now that we have that there are 20 terms in this sequence, I can substitute into the arithmetic series form in order to actually find the value of the arithmetic series. Let's go back to the board together. So now I'm substituting into Sn is equal to n over 2 times a plus L. My n is 20. I'm going to have a, which is negative 12. Then I'm going to add the value of the last term, which is 121. So that means if I take my calculator, I'm going to have 10 times negative 12 plus 121, which means the sum of this particular series is going to be Sn is equal to 1090. So at this point, the first two examples that I've done with you is we've seen that we can use the arithmetic series formula in order to determine the value of the series when I don't have L. But if I do have L, L being my last term, I use Tn to determine the number of terms in the series, and then I can calculate the arithmetic series using Sn is equal to n over 2 times a plus L. Let's have a look at the next example together. So for this example, I've been told that the sixth term of an arithmetic series is 32, and the sum of the first 9 terms in the sequence is 234. A is asking me to determine the nth term of the sequence, Remember that the nth term is then going to be asking me for the Tn. Then we are going to determine the first 3 terms of this sequence. So I need T1, T2, and T3. Let's just break down this example, everyone. The 6th term of an arithmetic series is 32. That means the T6 would have to be equal to 32. And the sum of the first 9 terms is 234, means that S9 is 234. Everyone, we are going to use the fact that we have information about a T and an S in order to solve simultaneously for A and D. On the next slide, I'm going to write down how I can do this. So please stay with me. You've got this. Let's do it together. So we've discussed that T6 is 32 and S9 is 234. I can replace T6 with A plus 5D. As it's an arithmetic sequence, I know that T6 is the same thing as A plus 5D. For S is equal to 9, I can replace S9. Sorry guys, I said S is equal to 9. I meant S9 is equal to 9 over 2 times 2A plus 8D. So all that I've done is I've replaced T6 with A plus 5D, and I've replaced S9 with 9 over 2 times 2A plus 8D. I'm going to be solving simultaneously for this, but first I'm going to isolate A on my left-hand side. So A will be equal to 32 minus 5D. I'm going to substitute this in on the right-hand side. So I'm going to have 9 over 2 times 2 times the A that I'm bringing across. So it's going to be 2 times 32 minus 5D plus 8D is equal to 234. Great, guys. So I'm going to divide this entire equation by 9 over 2 to make it slightly easier for me. So it's going to leave me with 2 times 32 minus 5D plus 8D is equal to 52. So I got that 52 by dividing 234 by 9 over 2. I'm now going to distribute this 2 in. So I'm going to have 64 minus 10D plus 8D is equal to 52. So if I simplify this even further, I'm going to be left with negative 2D is equal to negative 12. If I divide both sides by negative 2, D is equal to positive 6. I'm now going to take this positive 6 across. So A is going to be equal to 32 minus 5 times 6. So A will be equal to 32 minus 30. So A is equal to 2. Then if I'm writing this in the nth form, I'm going to have 2 plus n minus 1 times my D, which is 6. So Tn will be equal to 2 plus 6n minus 6. So Tn is equal to 6n minus 4. Great. Let's carry on with our working out. If we're going to determine the first 3 terms of this sequence, T1 will be equal to 6 times 1 minus 4, which gives me an answer of 2. T2 will be equal to 6 times 2 minus 4, which gives me 8. Then T3 will be equal to 6 times 3 minus 4, which will give me 14. Great, guys. So far we have worked with arithmetic series. After the break, I'm going to be doing geometric series. See you soon.